So Pat McCarthy, who is our director at NSF NOIRLab here, will sort of finish out our last talk of the day discussing the future.
Great. Thank you, Jennifer. Can you hear me?
Yes.
Aha, good. Now, let's see if you can see my slides.
And we can see your slides.
Perfect. All right, well, thank you so much, Jennifer, and thank the organizers for giving me this opportunity to talk about the future. It's always my favorite topic. But first, we're going to take a little look backwards, because it's always good to know where you've come from before planning for the future. We'll ask ourselves, what worked and take some lessons from the past. Then I'm going to talk about why I think the 2020s is the decade of the 8-meter class telescopes. We'll pivot a bit then and talk about the U.S. Decadal Survey for Astronomy and Astrophysics in the 2020s and what impact it might have when we see their report. And then just a little bit about setting the stage for what comes beyond the 2020s, and that might feed into the panel discussion that will follow. So let's first talk about the science landscape. I think this meeting has been quite interesting in showing the breadth of science that Gemini enables. We saw some great talks today just about the solar system from Meg. Really shows us about clues to formation and evolution and dynamics. Earlier in the week, we saw some fascinating talks about exoplanets, where we've really gone beyond detections, but now talking about atmospheric physics, about composition, about dynamics. It's really quite a burgeoning field. Lots of talks around interesting and extreme environments. Some good talks today about the extremes in kilinovae, detection of emerging neutron stars, that burgeoning field of multi-messenger astronomy that really probes some of the most unusual locations in the universe. And then much of what we've heard and been seeing from Gemini for years feeds into this our desire to understand the universe at large, the physics that drives it, in particular where galaxies come from and how they form and how they evolve. If you look by comparison then to the structure of the US Decadal Survey science panels, it's kind of interesting. So this is how the Decadal Survey has organized its thinking about scientific frontiers for the 2020s. You can see the topics actually map very well to what's gone on in this workshop and really what goes on within all of NOIRLab and Gemini, talking about these compact objects and their highly energetic phenomena, talking about the universe on the largest scales and the galaxies that fill it, and then locally looking at how stars and planets form, how exoplanets form and might host life, and then lastly coming back to our own solar system and asking what can it tell us about stars, about star formation, and ultimately about planets, and again, that search for life. So I think where we are now with our whole organization in Gemini is really very well aligned with the contemporary science, and particularly where we see the whole field of astrophysics moving in the next decade. And that's a great place to be. So let's look back a bit, because it's shocking to know how long it's been since the first 8-meter class telescopes went on the sky. It's been a bit over 20 years for Gemini, but it's coming up on 30 years for the first time, say, the first Keck telescope opened up the dome. So we might ask, what have we learned in these 2 to 3 decades of using 8-meter class telescopes? Well, we've learned a vast amount of science, a great deal about the universe that we didn't know. We've learned a lot that now we don't know that we thought we knew before, but we've also learned some lessons about observatories. And I think one of the key lessons is that continuous reinvestment is essential. It's so common in our field that we put a lot of effort and energy and resources into building an observatory, and then we starve it of instruments and we starve it of operational funds. And part of the keys to the success for Gemini has been continuous reinvestment in instruments and adaptive optics and other systems. That's what keeps the telescope forefront. That's what keeps it at the cutting edge. And that's done not by just allocating budget resources, but by building teams of scientists and engineers, in particular scientists at the universities or in our partner institutions who have an idea, have a passion for the science, understand what they want to accomplish, and work with skilled engineering teams to go from that vision to a fully integrated instrument on the telescope, working with the observatory staff to make sure that their vision can become a reality and that it can be useful for all of the users in our community. And I think we want to make sure that as we go forward to this decade, that we continue to support that investment in new technology and that team building and the partnering that's so essential to our success. One of the things we learned from the 8-meter era is that ground-based synergy is really powerful. And that was demonstrated early on with Keck and Hubble that came on the sky at about the same time. And together, the two of them were vastly more powerful than either would have been by itself. The fabulous imaging from Hubble, coupled with spectroscopy from Keck and others, really opened a whole new world in the distant universe. Since then, we've seen Gemini and others work with a whole host of space-based assets, whether that's in the gamma rays and X-rays, the far infrared. There's a lot of great science that comes by combining different parts of the spectrum, different ranges of resolution, both spatial and spectral, and leveraging that strength of the ground and space. And I think we're going to see more of that coming up in this decade. A key message, and I think we've seen this a lot today, is that innovation never goes out of style. And that while we may have the same platform that's the telescope, we can renew it not just by building instruments, but by changing the approach to how we use it and how we support science. And some of the innovative techniques that Gemini has brought for the long programs, the fast turnaround, the director's discretionary time. I don't know how many talks I've seen this week that stress the flexibility of Gemini, its ability to respond in a way that's tailored to the particular science problem, has really maximized its impact. So we need to keep thinking, we need to be agile, and we need to keep innovating, because there's lots of new things we can do with these tools, despite the fact that they're getting fairly mature. We should also be a bit sober about how long it takes to develop technology. There's some interesting examples. The time between the first photograph taken and when photography really became a widespread, both popular and scientific application, really at its zenith, was well over a century. And it took about 25 years from the invention of the first CCD to completely drive photography more or less out of the marketplace. So innovation, while it can be agile and quick, technology often takes time to really sink in and reach its full maturity. And we see that in the construction of observatories. It was close to 50 years between the dedication of the Palomar 5 meter and that for the first 8 to 10 meter telescope, the Keck 10 meter. And it's going to be 35 to 40 years between first light on the first 8 meters and first light on the ELTs. It just takes a long time to build these big systems and for the technology to mature to allow that next big step. I think that's important to keep in mind when we look at some technology we're wrestling with today. Adaptive optics is still a relatively new technology. The concept might be older than most of us on this call, but the technology itself has only been around for a few decades, and we're still learning how to use it and how to build it and how to optimize it. So I view the future for adaptive optics is bright because there's a lot of room for innovation still. It's still a relatively new technology. So my takeaways from looking back is that we need to invest early, we need to continue to invest, we need to build and maintain and sustain our partnerships, and we have to be patient, but just keep pushing because it takes persistence to make these things really pay off. So if we look forward, I'm convinced that the 2020s is the era of the 8 meter telescopes, both on the ground and in space. Webb is, it's an 8 meter class telescope. It will have diffraction limited imaging that's comparable to the 8 meters, working out at longer wavelengths. Its sensitivity in the thermal infrared will be really unrivaled by anything. It's going to be spectacular. And I think it's going to rejuvenate this ground space synergy that we saw with Hubble and we've seen in the gamma rays and X-rays. And I think we've already seen at this meeting people who showed exciting Gemini science and said, oh, this great result from Gemini helped me get time on Webb on cycle 1. And I think in a little while, we'll see that go the other way. People have their exciting Webb data, and they're going to want to come to Gemini and other telescopes and get that spectroscopy, the AO imaging, the other wavelengths. That synergy, I think, is poised for a real rebirth when Webb launches and we continue to build out our adaptive optics capabilities on the ground. And I'm already seeing Joanne's stars picking up. So the Rubin Observatory is coming soon. So we'll have lots and lots of imaging, but remember, spectroscopy is what drives astrophysics, and the combination of Rubin and faint spectroscopy is going to open up whole new windows, not just in the time domain, but in the static sky as well. And this is just illustrated in this nice little diagram showing the imaging depth of Rubin and some infrared space telescopes, Euclid and Roman, that are coming, and how Gemini can push well into that imaging domain with the spectroscopy, followed by Webb, and then eventually the ELTs. It'll be able to get spectra of essentially anything in the Rubin static sky and most anything in the Roman survey images as well. As I said, AO is still a young technology, but it is the future. The 4 meter telescopes really delivered on their full promise once they cleaned up their image quality and got digital detectors in to replace photographic plates. And now the 8 meters with AO, they're reaching their theoretical limit. And so they're performing almost as well as they can. There's a little more room to push, and that's what's going to make this so powerful. And they are the key. AO and digital detectors, low noise devices, that's what will drive the performance of the extremely large telescopes. And Gemini and others, they're the pathfinders for that. And so it's important that we keep reinvesting and finding the right technical paths forward. So the US Decadal Survey is coming to a conclusion. That's the body that will set our scientific priorities for the decade and our priorities for investment in the federal agencies. I don't know what they're going to predict or prioritize for the big projects. I think it's pretty safe that they're going to advise us to invest in data archives, to invest in high value data products, to include more people into our communities, those who've not been able to participate, and to engage more closely and with more respect the local and indigenous people around our observatories, and to reduce our carbon footprint and be good as citizens and make our observatories green. And all of these things are in our vision for the future, and we're committed to moving forward on all of these initiatives. In that vein, the themes for the NOIRLab in the 2020s are to become the leading resource in time domain astronomy. We heard about that from Monica and Brian. To push high precision astronomy, whether that's adaptive optics, precision radio velocity, spectroscopy, lead the world in survey astronomy, and of course, engage the community and really be an agent for positive change in our field. And Gemini touches all of these boxes. And then when we bring the entire lab together with Gemini, Rubin, the mid-scale observatories, this is our theme, our vision for the 2020s. We look out then, how are we going to build this from a science perspective? One of our themes is we want to image the sky in depth, in color, and in motion. And we'll do that with our wide field imagers and the precision cameras. We'll do that with ground space synergy, and we'll do that in the time domain, as we saw from Brian, by building these intelligent networks that connect Rubin to Gemini, to SOAR, to suites of small telescopes, and open up that new domain. So lastly, if we just step back and look to the long-term future, what do we see coming in the future decades? Well, first and foremost, we want to continue to invest in Gemini, and not just in its operations, but in development of new technology, because that's going to push science for some time. We've got some interesting experiments going on in dark energy. We've got the Rubin Observatory coming in just a few years. We'll have to build something that uses those facilities afterwards. We may have, one or more, hopefully 2 30-meter class telescopes built with US involvement and operating in the 2030s and beyond. And at some point, we need to think about what's the next big thing. In order to do that, we need to start planning. We need to invest in technology. We need to build the community and make those plans for the next generation of young, clever people who will do interesting excitement. And that, of course, is all driven around this decadal process that's coming to a conclusion now. But once that's over, it's time to catch our breath and start thinking about the next decade. So it's been a bit of a whirlwind tour. I think we've learned a lot, but the future is very bright. And I think the next decade is going to be an exciting time for all of us, particularly for those of us in the NOIRLab community and Gemini in particular. So thank you for giving me the opportunity to just share my thoughts on how I see the future. And back to you, Jennifer.
Wonderful. Thanks so much, Pat. Let's see. There are no questions yet, so get those questions in, everyone. In the meantime, my question for you is there a specific astronomical question that you hope is, or excited about maybe being answered with the help of Gemini over the next decade or so?
The big question that I hope that I'm around long enough to see the answer, but I'm convinced that some of you will be, is there compelling evidence for life elsewhere in the universe? And I think we will actually have the answer to that in the next maybe decade, maybe more. So I'd like to be around to see that happen. I think some of the results we've seen about atmospheric spectroscopy this week point the way. It maybe that's too hard of a question for the 8 meters, but finding the right systems, developing the right techniques, setting the stage, that's a huge contribution. We would never get there if we don't do that with the techniques and the tools that we have now. And I'm very optimistic on what I've seen in the past few years. That with precision spectrographs in the visible and the infrared, we have a good chance of seeing the atmospheric signs of biology in exoplanets.
Fantastic. Yes, I've only been here for 6 months, but seeing the wonderful things we can do when observing, it's fantastic. Let's see, there are any other questions, anyone? Everyone seems to have, maybe everyone's taking their break right now. So then another question, since you are the NSF NOIRLab director, how do you see the non-Gemini telescopes contributing together with Gemini in the future? Or what sort of unique capabilities are they adding to the Gemini telescopes that maybe weren't working before NOIRLab?
Yeah, well, we saw a bit of that in the discussion from Brian around the time domain, but I think there's a lot going on in this what we might call the static sky that is powerful but less appreciated. So the very large sky surveys, like the Dark Energy Survey, what will come out of Rubin, the spectroscopic survey coming out of DESI, they find interesting rare objects. So whether that be quasars beyond redshift 6 or something that are probes of the early intergalactic medium. Those big surveys are the hunting ground for the really interesting systems that then you can go back and study with Gemini with its narrow field, high quality, high contrast imaging AO. Gemini is not so much an instrument for surveying large patches of the sky, but when you know where you want to look, that's where it's powerful. And now by having all of that sort of under one roof, I think we can leverage that more effectively, not just in the time domain, but also all kinds of different areas of parameter space and color space and color magnitude space to find those interesting rare objects that often tell you an awful lot about what's going on that you can't learn from huge samples of sort of run-of-the-mill objects.
Wonderful. Let's see. Oh, and we do have some questions coming in. One is NOIRLab seeking collaboration with other observatories specifically to help achieve the decadal survey goals?
Indeed. And when we know what those goals are, that will make it easier to. But I think some of the things that are more structural and social to the field about bringing other people in, building data archives that are robust and useful to a large segment of people, those are conversations we're already having now. I think there's a general sense building within the field that we need to get everything out of every bit of data that we can, that we need to treat our mountaintops in a way that minimizes our footprint and shares them with local people, that we need to bring more people into the field. And so those are things that are happening across the field. And we're having good conversations with other observatories around those very issues. But we're also talking to people who are interested in massive spectroscopic survey telescopes. We're talking to the ELT project. So when we see the direction on the big projects, we've already built a lot of that groundwork to move in those directions of working in partnership with those groups. We just need to know what the direction is, and hopefully we'll know pretty soon.
Wonderful. So then another question about instruments from Zach is, for both Gemini and beyond to other NOIRLab telescopes, is it more likely that new instruments will be focused increasingly on specific science questions, or is there going to be space for new general use instruments to be developed?
Oh, I think there's space, but particularly in Gemini, I think Jennifer Lotz works with her the GSTAC, the Gemini Science and Technology Advisory Committee, to get their guidance. She works with the Gemini Users Committee to gauge their interests. So we're very much tuned into what does the community want, what do the technical experts think is feasible, and that will drive which way this goes. Whether it's things that are very specific, and we've seen some really powerful examples, say with Maroon X, the things that are very broad like GMOS and maybe, daughter of GMOS, whatever is coming, I'm hoping that will be a general purpose instrument. So I think there'll be a good balance, but it's driven by the community, and the Gemini leadership is very responsive to that input. And I'm sure that they're going to think carefully about what comes next after the many exciting things in the pipeline you've already heard about this week.
Great. And then one final question before we move over to the panel. So Meg wants to know that, so Gemini has been groundbreaking in international scale partnerships in large observing facilities. So how is NOIRLab utilizing that expertise and experience from Gemini as Rubin Observatory and the US involved 30-meter telescope progress?
I think we've seen examples this week and over many years of how Gemini's used its international partnerships to leverage interesting and important contributions. ones that are just coming are IGRINs and IGRINs 2. Many of the instruments that are powerful now have come out of Canada. Some have come out of Australia in partnership. So I think the partnership has been very vital and engaged in building instruments and setting directions. We're always looking for new ideas and new people to bring into the fold. And on the ELTs, of course, when you look at the combined global community within the Giant Magellan Telescope and the TMT, they cover pretty much every country that's interested or really a player in astronomy that's not in Europe. And so when thinking about to find new partners, say in the ELT sphere, I looked around the entire globe and was thinking, surely there must be more countries, because everyone who's a player in astronomy is in one of those groups or another, with a few exceptions. And we should be working on those few and to try to bring them into the fold. Like thinking like, Taiwan, for an example, is a great astronomy group, technically capable. It would be nice if we could find a way to get them into some of these big projects. So, astronomy has made the world much, much smaller. Those international partnerships are vital to all of us, and we need to just keep building on them and nurturing them. But we're pretty well connected. And Reuben, while it's being built in the US, the technical and scientific network is very broad, and it's very well connected all across Europe, parts of Asia as well, even parts of South America and Latin America. So it's a much more diverse project than you might guess just by looking at the hardware itself.
Great. All right. Thanks so much, Pat. And actually, you're going to stay on. I'm going to hand it over to Janice, and we will start the panel discussion then.